Hello everyone, good morning. Welcome me back in the science. After such a long time, we are working for science. We are working on force and pressure for few students in one of the school. This topic is there for their PT1. So in case if this topic is not there for you for your syllabus, you can stop watching this video. You can prepare your PT1, and later on after finishing your PT1, after your PT1 finishes, after your revision finishes everything, then you can watch this video will be still there. So those who have got this topic, let us continue with them. The force and pressure, in this particular video we'll be completing force, and in the next video we'll be completing pressure. One of the very fantastic topic, fabulous topic, my favorite, that is force. One should understand exactly what is the force. We are working on the physics. Let me tell you, physics is considered to be something which is not visual. That means we cannot see the concepts of physics, how we can feel it. That's the reason physics is something which is not visual. We have to understand it, we have to feel it. And that's why somewhere few people consider physics is bit difficult. But let me tell you, physics is magic. It is just a magic which you cannot see, and which we see or which we feel that it is happening. Okay, it's just like a magic. So let us come into the world of magic. And the first concept that what we're going to learn this year is nothing but force. Before we start understanding force, let us know about push and pull. What do you exactly mean by push and pull? To know that, I have a very simple activity which is given in the textbook itself, that there are some situations given. You have to identify whether it will fall in push, or it will fall in pull, or it can be both. Depend. Okay, so let's understand what exactly the action is. So what you have to do is moving a book placed on a table. So this is how we have something which is moving a book from the table. So it can be even pushed, it can be pulled. That means it can be pushed it will be pushed forward. The book can be pulled towards you. It can be lifted up, right? So what I can consider this as, of course, the pushing is there, we have a pulling. Lifting is again a pulling itself. When you lift something, it is pulled towards you, right? The object is pulled towards you. So this can be easily classified into push and pull. Opening or shutting the door. If you open the door, it is pulling. If you shut the door, it is pushing, right? So it is, yes, it can be considered both push and pull. Drawing the bucket of water from the well. From the well, you are drawing the bucket, so that means it is pulling. And yes, it can be, pulled. Okay, pushed is not pushed by basically. A football player take a penalty kick. That means he hits the ball. When he is hitting the ball, it is actually kicking. Okay, he's kicking, he's hitting. And how can the kicking classified as pushing or pulling? Yes, it is pushing. Right? Clear. Pushing the ball towards the goal post. Right? A cricket ball is hit by the batsman. It is again a hitting. Right? Is hitting. And what is it exactly? Pushing. Right? It is pushing towards the boundary line. So it is like that. Moving a loaded cart. Okay, so it is again a pushing, right? Moving a loaded cart, it is pushing. And yes, it is pushing but not pulling. Opening a drawer, it is pulling. Okay, so it is not pushing, it is pulling. Opening a drawer. So what we understand? We understand whatever things we are doing, it is either pushing or pulling. Whenever we see things happening, it is either push or a pull, right? And to push and pull, we need to apply something, and that is called as a force, right? That is called as a force. So when force is applied to the object to pull or push, okay, or to pull or push, we need to apply the force on the object particularly, right? Let's move ahead now. Let's know about force. What is force? So let us know the definition given in the textbook itself. Okay, what is force? A push or a pull on an object called as a force. Let us not change that definition. Let us know the definition as it is. The push or pull, the push or pull, what is it? The push or pull on an object called as a force. Very simple. On an object called as force. Right? So very important definition. What is force? The push or a pull on an object, we call it as force. But let us know more about force. So it was just a simple part of the force that what we learned it right now. Okay, either pushing or pulling we call it as force. फोर्स के कुछ सिग्निफिकेंस देखते हैं, सम फेनोमेनन्स या फिर प्रॉपर्टीज देखते हैं उसके, तो क्या होता क्या है, फोर्स क्या होता है, लेट्स अंडरस्टैंड. तो कुछ एक्टिविटीज देखते हैं अभी. कोई भी फोर्स इन केस इफ इट इज अप्लाइंग देन डोंट यू थिंक कि द फोर्स starts acting on the object when it comes in contact. Now, for an example, you and your friends are fighting with each other. So when you fight with each other, isn't it to hit your friend or to push your friend, you need to contact him, you need to touch him, right? So isn't it force happens due to interaction? That's one thing we understand. It's not only that, even during a tug of war, when you pull each other, isn't it you hold the rope in your hand? So we need to come in contact with it, right? So these are called as a contact forces. Okay, we need some interaction to happen, right? Somewhere or some forces need not to have contact. For an example, like a magnetic force, when a magnet is attracting a nail, it need not to have a contact with each other, right? Like a gravitational force, even gravity is pulling the object down, and there it need not to have a contact. So such forces we call as a non-contact force, right? So we understood that we have two different types of forces. One is contact force and second is non-contact force. We are going to talk about these forces in a later slide. But in this slide, let us know more about actual force. Right? Now, for an example, imagine if you have a box here and you are pushing the box from one direction. Right? You are pushing the box. So don't you think if you are able to do that, of course, the box will move in this direction. Now imagine your friend is also pushing the box towards you. He is pushing the box towards you. Okay? Now what do you think? Isn't it you need more force applied to the box so that the box will move towards him? In case if you apply the equal forces, the box, will it move? Yes, it won't move. Now what do we understand here? We understand here that the force whenever is applied, it has got a two different concept. One is a strength, that is magnitude. That means the quantity of the force and how much force you are applying. That is called as a magnitude. The strength of force is called as a magnitude, or the quantity of the force is called as a magnitude. How much force you are applying, that quantity is called as a magnitude. How much force your friend is applying, that quantity is nothing but called as a magnitude. But do you think the force can be defined just by using magnitude? No. Isn't it the force also needed direction to understand? Because you can see that you are applying the force in this direction and your friend is applying the force in this direction, and even then both of you are applying the force, the box is not moving. Isn't it? In case if I say that without drawing the diagram, if I just say that you and your friend both are applying a force on a box, what you would say? Yes, then the box will move. But after that, when I draw the diagram and I show you the direction, that time you will say that no, box will not move because they're applying the force in the opposite direction. Exactly correct. So don't you think only force is applied is not enough? Force is applied in which direction, that is also going to matter in this particular concept of force. Right? So to understand force, it's not only magnitude is enough, but even direction is required. Right? Imagine you and your friend both are pushing this particular box from the same direction. Okay, at the same direction from the one side you are pushing the box. So isn't it will be very easy for you to move the box, right? If you are both of you are pulling it or pushing it rather from the same direction. So if your friend is also doing the same thing, okay, so both are pushing in the same direction, don't you think the box it will be very easy to move it, right? That means when you apply a force in same direction, the forces get added to same direction, then the force will get added. That means the magnitude gets added. And if it is different direction or opposite direction, the force gets subtracted. Right? So that's what we understood from this one. Right? So why this example I took it to make you understand that the force need magnitude, that means a value, that means a quantity, or you can say the strength, as well as the force need direction to understand. That's it. Let's know what is the effect of force. That means what happens when the force is applied. Okay, what happens? What happens when the force is applied? Do you know what happens when the force is applied? Okay, when force is applied, the object will move. है ना? Suppose imagine if there is an object will move. If you apply some force, object will move. Okay, so if the book is kept on the table, isn't it? If you apply some force, the book will move from one place to other place. So when the object is at the rest, it will set a motion. It will set in the motion. So that's the effect of force. What if a cricket player stops a ball which has been hit by a batsman? Do you think he also applies a force to the ball to stop it? So hard hit the ball by the batsman is needed to stop. Isn't it the fielder need to apply some force on the ball, then only it will stop? Exactly correct. So what is the second point is the force is also required to bring the object at the rest. To bring the object at rest. So force is required to give motion as well as force is required to bring the object at rest. Third one, one thing I'll tell you, I forgot to tell you that we have electricity issue on Monday, so I'm not able to prepare the PPT for you for the science. Okay, so I'm just explaining you on this board. Tomorrow I may do that. Fine. Okay. Anyway, let's understand what happens when you apply the force to bring the object at rest. To set an object in the motion, we need force. When it comes to cricket, I'll just tell you one more thing. Suppose imagine the bowler is bowling, okay, and batsman want to shot it or wants to hit the ball towards the offside. So what the batsman does? Batsman just give the direction with the bat. Okay, so batsman what he does? Ball is moving towards the keeper. He changed the direction of the ball. So what do you think? To change the direction of the ball, is batsman needed to apply some force? Of course, yes. So what the force do? It changes the direction, right? Force also does the change in the directions. Force also bring the change in the direction, right? And finally, force also changes the shape of the object. Changes the shape. So now what we understand here, what force do? The force changes the motion. So if it is in the rest, it will bring in the motion, or if it is in the motion, it might bring in to the rest. Force can change the direction of the moving object. Okay, very clear. Moving object. And force can change the shape of the object. Now, for example, a clay, isn't it? We need if a potter making a pot out of a clay, isn't it? He has to apply some force on the clay, right? So that's what, when we apply force on something, it might change its shape. So this is what we see what happens when we apply the force, and that's called as a effect of force. What we call it as effect of force. So what happens when the force is applied? Clear? So let's know what we have seen till this time. Let's revise it. Everything that what we do, we see, can be classified as push or pull. Whatever we push or pull on the object, we call it as force. That means when we push or when we pull, we need to apply the force on the object. Force cannot be just defined by magnitude, that means the quantity of the force. It also defined by the direction, that means direction is also required. So उसके लिए मैंने एक simple सा example दिया था. If I ask you that there is a 10 kg of a box and you and your friend are pushing it, then what do you say? That 10 kg of box will move or it won't move? If your answer is yes, it will surely move because it's just a 10 kg and you both of you are applying the force, it will surely move. Then I will say that what if you are applying the force from opposite direction? Then you will say what? Yes, we cannot move it. That means what? Force cannot be just justified by magnitude, it also need direction to understand. This is what we have seen. And lastly, finally, we saw that the effect of force क्या होता है. That means what happens when a object is applied a force? It changes its motion, it changes its direction, and it changes its shape. So three things we have seen when force is applied. Final part, last part, is a types of forces. We have seen the force is either push or pull. But there are two types of forces. One is a contact force and second is non-contact force. Contact force means what? Where we need interaction, where we need touch, the contact. Those are called as a contact force. So which are the contact forces? First one is a muscular force. So whatever forces we have seen till this time, all are muscular forces. That means a bull is pulling a bullock cart is of course a muscular force. You riding a bicycle, of course a muscular force, right? So whatever examples we have seen till this time are nothing but what do you say, a muscular force, right? There are so many other forces also, that is structural forces, so many different forces we have. But for your syllabus we have only two types of forces. One is muscular force and second is frictional force for the contact force. What is frictional force and how is that been applied, and how that we don't know till this time. What is frictional force? When a car when a car or car driver applies a brake, uh, moving that particular car on the road, the car suddenly stops, right? What do you think? Isn't it that brake is nothing but friction between that brake plate and a tire? Imagine the road is not rough as we see, it is very smooth like ice. Do you think even after applying a brake, the car will stop? No, it will skid on that particular smooth surface. That means the road is rough. That's the reason we are able to stop our car. And what makes that car to stop there on the road is nothing but a friction between the tire and the road. That's called as a friction. Tire moves in the opposite direction and the friction, that is the road, applies a friction in the opposite direction. So road applies a friction in this direction and tire moves in this direction. We call this as a friction. I can give you a very simple example. Take your two palms and just slide it over each other very vigorously. Just slide it over each other. You will find, or you will feel after some time, your hands are becoming bit warm. That is due to friction. This is due to friction. Right, I hope you are understanding. Friction forces you are understanding, and you can see that your both the palms are moving in the opposite direction. One is coming towards you and the other is going away from you, and that's opposite direction. The friction force is always in the opposite direction. Friction force is also required for walking. Let me tell you, you may not understand that, but yes, friction force is surely required for walking. Right, we need friction force. We need friction between your legs and the land. We need friction, otherwise you will fall down. That's the reason, during this rainy season on the plain surface, if there is a water falling down, then you might slip over there, because you cannot walk on the slippery surfaces. The reason is the friction is less. Why you cannot walk on the slippery surfaces? The reason is this: there is no friction. Right, is this clear? I hope you are understanding. So this is the friction force. Two types of forces or contact forces we have checked, that is muscular force and the frictional force. At the same time, the other one we need to understand, that is non-contact force. What a non-contact force? One is of course magnetic, that what we have seen. When a particular magnet is pulling a nail, isn't it, we cannot see that it is in contact, but of course we feel that there is a some force by each other. When north pole and north pole of the magnet, when they come closer to each other, they repel. That repulsion is not with the contact. That repulsion is without contact. Right? They move, they separate from each other quickly, suddenly. This is nothing but without coming in contact. So that is what we call as a magical force. That is non-contact force, magnetic force. Similarly, we know electrostatic force as well. What is electrostatic force? Just imagine you're rubbing a comb on your hair and keeping small pieces of paper near the comb. Isn't it? The piece of paper will, attract towards the comb. Yes, it will attract, and that is the force called as the electrostatic force. The comb gets charged when it is rubbed on your hair, and this charged particle or this charged comb attracts uncharged pieces of paper. Charge, that means there is some energy in it. So where we find electrostatic force? So many places we find electrostatic force. If you have got a screen or TV around you, just go and take your hand towards your screen of the TV. You will find hair on your hand uh, will attracted by the screen of the TV. We call this force is nothing but electrostatic force. There is a very simple and interesting example of electrostatic force is nothing but thundering. When we feel thundering, which is a very strong force, natural force, is also an electrostatic force. Let me tell you, if you want, you can search about thundering, why thundering happens. Okay, or you must have studied this in the previous grades as well, that why thundering happens, or maybe this year you are learning again. But yes, it is due to electrostatic force. Right. Gravity, the another non-contact force is a gravity, invented by a great scientist Newton. We all know about him. So what gravity does? Gravity also pulls the object towards it, and that is non-contact force. We know that Earth pulls all the object towards it, right? But do you think that only Earth pulls? Yes, no. Moon, sun, all the heavenly bodies also have the gravity. But do you think that only planets have the gravity? Only stars have the gravity? No. Any object around you, if you take, they have a gravity in them. They have their own gravity, let me tell you. And this is what the Newton says. Everyone has got this kind of a misunderstanding that only planet, that heavenly bodies, has got gravitation force. But the fact is, all the objects around you have got a gravity in it. They attract each other. As they're very small, their gravitation is also very, very small, and that's the reason we cannot feel that attraction. But yes, every object around you has got a gravity or gravitational force. So that's it. I hope you understood till here. The force concept you must have got it. कि exactly क्या force होता है, types of forces we have seen, effect of forces we have seen. Very small topic है, कुछ ज़्यादा difficult नहीं है, इसमें activity ज़्यादा है, unnecessary activity ज़्यादा है. तो चलो force तो हमारा खत्म हो गया. That's it. Easy था, बहुत simple था. Thank you so much. Bye bye. See you in the next class. This is what the force is, complete forces. See you in the next class with the pressure, and that's again a very, very interesting concept. So we'll be learning that in the tomorrow's class. Till then, and we are going to finish this topic tomorrow. Till then, bye bye. See you tomorrow.